In our last class, we had discussed that is the Kanis method, how to find out that rotational moment and how to get the final moments when the supports are at the same level. So today we'll discuss one problem. Determine the support moments for the continuous beam. The relative I values are indicated along the member in each span is constant. This is your 3-span continuous beam with ends 1 and 4 is your fixed. And having load 80 kilonewton at a distance 1 meter from support 1, and the length of the beam is 3 meter. Then for 2-3 span the length is 4 meter, and for 3-4 span the length is 4 meter. And in 2-3 span there is having UDL 50 kilonewton by meter throughout the span. And in a 3-4 span there is having the concentrated load 40 kilonewton at the midpoint. So first you have to find out the fixed end moments. You have to assume all ends are fixed and you have to find out the fixed end moments. So for span 1-2, MF12 and MF21, MF12 minus, this is the eccentrical load WA square by L square. For eccentrical node, what is the moment, what is the fixed end moment at the end? MF12 is your minus 80 into 1 into 2 square by 3 square. And for MF21, plus 80 into 1 square into 2 by 3 square. 1 square into 2 by 3 square. The clockwise moment is your positive and anti-clockwise moment is your negative. That already we discussed in theory. Then for 2-3, so MF23 and MF32, because this is UDL. So for UDL, what is the fixed end moment at the end? WL square by 12, and for anti-clockwise minus WL square by 12, and for this is clockwise plus WL square by 12. 50 and L is your 4, 50 into 4 square by 12. Here 50 into 4 square by 12, and for this anti-clockwise you are taking here negative, and for clockwise this is positive. Then this is the span 3-4, and what is the fixed end moment? MF34 and MF43. MF34 is your, that is when there is your having the concentrated load at the midpoint. So what is the moment? WL by 8, For this side, anti-clockwise minus WL by 8. W is your 40, L is 4 by 8. 40 into 4 by 8. Minus 20 kilonewton meter, and MF43 plus 40 into 4 into 40 into 4 by 8 plus 20 kilonewton meter. So this is the fixed end moments for end of the all span. Then the next step is you have to find out the relative stiffness of the members and rotation factors. Using this type of tabular form, you have to find out what is the relative stiffness of the members. Here you see the joint 2 and joint 3. There is your 2 joints. Intermediate joint 2, 3. So first you in the tabular form. So first column is your joint, second member, third column is your indicate relative stiffness of the member. Then fourth column is your the summation of the relative stiffness at the joint. Summation of relative stiffness at the joint. Then rotation factor for the members. Rotation factor. This is the formula. U is equal to minus half into K by summation of K. This is the formula already we discussed in the last class. Here you take 2 joint, 2, 3 joint, then member. At 2 joint, how many member meets? 2 member, 2, 1 and 2, 3. At joint 2, there is your 2 member meets, 2, 1 and 2, 3. 2, 1, 2, 3. Similarly, at joint 3, how many member meets? 2 member meets, 3, 2 and 3, 4. 3, 2 and 3, 4. So this is the member and this is the joint. Then you have to write the relative stiffness, because here ends are fixed. What is the relative stiffness of each span? Because when end of the beam is your fixed, so for that end span is your I by L, and also for intermediate span is also for I by L. So here end is your fixed. So what is the relative stiffness of span AB? Span 1-2. What is the relative stiffness for span 1-2? The moment of inertia is given 1.5 I, and the length of the member is your 3. So 1.5 I by 3. 1.5 I by 3. Relative stiffness for member 2-1. Similarly, for this one, 2-3. What is the relative stiffness for span 2-3? 2, 3. Here the moment of inertia is given 2I and the length of the span is your 4 meter. So relative stiffness is your 2I by 4. 2I by 4. Relative stiffness is your I by L. So here the moment of inertia is given 2I and length is your 4. So 2I by 4. Similarly, take this one, joint 3. So at joint 3, there is 2 member, 3 2 member and 3 4 member. 3 2 member, 3 4 member. So for 3 2 member is also, for 3 2 member, what is the relative stiffness? So same 2I by 4, 2I and 4, 2I by 4. Then 3 4, for 3 4 member, what is the relative stiffness? Here you see this is the moment of inertia and the span of the 3 4 is your 4 meter. Span of 3 4 is 4 meter. So here the relative stiffness is I by 4. I by 4. So this is the relative stiffness of the member. Then you have to find out the relative stiffness of the joint. Here you see at the joint 2, there is 2 member meets, 2 1 and 2 3. So what is the relative stiffness of the joint 2? What is the relative stiffness of joint 2? So joint 2 K2, the relative stiffness of joint 2 is your K2. K2 is your equal to K21 plus K23. So this is your 21 and this is 23. So the what is the relative stiffness of 21? K21, this one. And what is the relative stiffness K23? This one. So this plus this 1.5I by 3 plus 2I by 4. So this summation is your equal to I. So the summation, the relative stiffness of joint 2 is your equal to K21 plus K23. So you have to add these two relative stiffness, then you will get what is the relative stiffness for joint 2. This is 1.5I by 3 plus 2I by 4 is your equal to I. Similarly, find out what is the relative stiffness of the joint 3. You see at joint 3, how many member meets? 2 member meets, 3 2 and 3 4. You know what is the relative stiffness of 3 4? 3 2, and you know what is the relative stiffness of 3 4. So K3 is your equal to K32 plus K34. So here you know the relative stiffness of 3 2 is your 3 2 is 2I by 4, and the relative stiffness of 3 4 is your I by 4. So after by adding these two relative stiffness of the member, so you will get what is the relative stiffness of the joint. So the summation of K is your equal to 3I by 4. 2I by 4 plus I by 4 is your equal to 3I by 4. First you have to find out the relative stiffness of the member. Then you have to find out the relative stiffness of the joint 2 and 3. Then you have to find out what is the rotation factor. So you know this is the rotation factor. This is the rotation factor formula already we discussed in last class. So U is equal to minus half the relative stiffness of the member divided by the relative stiffness of the joint. So here you see this is the relative stiffness of the joint and this is the relative stiffness of the member. You have to find out the rotation factor. So the rotation factor U is equal to minus half into KB by summation of KB. So minus half into KB means this one. This is the relative stiffness of the member, and divided by summation of K means this one. So minus half into 1.5I by 3 divided by I. After this you will get the value here minus 1 by 4. Similarly, find out the rotation factor for 2 3. Find out the rotation factor for 2 3. This is 2 1, you got this one, and for 2 3. So what you have to do? So U is equal to minus half into this is the relative stiffness of the member divided by the relative stiffness of the joint. So minus half into 2I by 4 divided by I. So you will get minus 1 by 4. Then coming to the joint 3. So at joint 3, there is 2 members. So you have to find out what is the rotation factor for 3 2, and you have to find out what is the rotation factor for 3 4. So when you want to find out the rotation factor for 3 2, so what you have to do? Minus half into K32 divided by K3. Minus half K3 to this one and K3 this one. This is K3. This is the K3. So minus half into 2I by 4 divided by 3I by 4. So you will get the value minus 1 by 3. Similarly, for this one, you have to find out what is the rotation factor of 3 4. So for 3 4, U 3 4 is equal to minus half K34 divided by K3. So here K34 is your this one and K3 is your this one. K3 is your this one. You have to find out this value. So minus half into I by 4, relative stiffness of the member, divided by the relative stiffness of the joint 3. So 3I by 4. So after this, you will get this is the value. So always you have to check. So at the joint, the sum of the rotation factor should be minus half. Always at each joint, the sum of the rotation factor should be minus half. So here you see this is minus 1 by 4, this is minus 1 by 4. So what is the summation of these two value at joint 2? So this is minus half, and here also at joint 3. For 3-2 member, this is the rotation factor, and for 3-4 member, this is the rotation factor. So what is the sum of these two rotation factor? Here this is also minus half. So always you have to check whether the sum of the rotation factor is your coming minus half or not. If that is not coming minus half, then your calculation is wrong. If you are getting that minus half, then your calculation is correct. That's why always you have to check the sum of the rotation factor at each joint should be minus half. Okay, so then after calculating the rotation factor, then what is the next step? Then you have to find out the rotational moments. Using this rotation factor, you have to find out the rotational moment. For this rotational moment, so you need what is the sum of piston moment at 2 and what is the sum of piston moment at 3. You see, so what is the sum, because you know what is the piston moment 2-1 and what is the piston moment 2-3. You know MF21 and MF23. So what is the moment at 2? M2 is equal to MF21 plus MF23. MF21 is your 17.78 and MF23 is your minus 66.67. So you will get the piston moment at 2 is your MF2 is equal to MF21 plus MF23. 17.78 minus 66.67. So this is your minus 48.89 kilonewton meter. Similarly, you have to find out what is the sum of the moment at 3. MF3. MF3 is equal to MF32 plus MF34. You know MF32 is your this one and MF34 is this one. So you'll get MF3 is equal to 66.67 minus 20. So this is equal to 46.67 kilonewton meter. You see, this is you got the piston moment at joint 2 your minus 48.89 and piston moment at joint 3 your MF3 your plus 46.67 kilonewton meter. Then you have to find out the rotation moments. So the rotation moment you can find out in a tabular form. This first step to go for the first cycle. So what you have to do, here you see, you have to draw this type of box. You have to draw because 1, 2, 3, 4. So this is your 1 fixed and the 4 is your fixed, and in 2 joint you have to draw this type of box, and at the 3 joint you have to draw this type of box. So in middle rectangular box you have to write the piston moment of joint. So you got the piston moment of joint 2. Joint 2 is your minus 48.89. You have to write here. And the sum of piston moment at joint 3, you got 46.67. So you have to write here. And you know what is the rotation factor 2-1, 2-3, 3-2, and 3-4. So here you got 2-1 rotation factor is your minus 1 by 4, 2-3 rotation factor minus 1 by 4, 3-2 rotation factor minus 1 by 3, 3-4 rotation factor minus 1 by 6. So here you have to put. So this box 2-1, this box for 2-1, and this box for 2-3, and here also this box for 3-2, and this box for 3-4. So you have to put here the rotation factor in the corresponding box. Then you know what is the piston moment. Here you know this is the piston moment MF12. MF12 means this one, MF21 this one, MF23 this one, MF32 this one, MF34 this one, MF43 this one. So you know the piston moment at the end of each member. So here you have to put this is your MF12, this is MF21, and this is MF23, this is MF32, this is MF34, and this is MF43. This is the line. This is the line. So above this line, you have to write the piston moment of end of each member. So now clear. So first you have to draw this type of one line. Then at joint 2 and 3 you have to draw this type of box, and this is the end. So just above the line you have to write the piston moment, and for the joint piston moment you have to write in this box piston moment of the joint here, right? And the rotational factor you have to write here, this box you have to write in this box. So this is the piston moment of the member, piston moment of the joint, and the rotation factor. First you have to write this type in here first. Then you have to find out the rotation moment. These are the rotation moment. These are the rotation moment that you have to find out. You see, if the end of the member is your fixed, so the rotational moment and rotation factor at the end of the member is your 0. The rotation factor is your 0, and so that the rotational moment is also 0 if the end of the member is your fixed. You have to find out the rotational moment of m dash to 1. So this rotational moment you have to designate by dash. M dash to 1, M dash to 3, just already we had discussed. And piston moment is your MF, M subscript F, 1, 2, 2, 1, 2, 3, 3, 2, just. And for rotational M dash 1, 2, M dash 2, 1, M dash 2, 3, M dash 3, 2. So you have to, so here you see these are the rotational moment. So this is 2, 1, this is 2, 3. So M dash 2, 1 you have to put here, and M dash 2, 3 you have to put here, and M dash 3, 2 you have to put here, and M dash 3, 4 you have to put here. And the rotational moment is your 0 because this is the piston. So first we will start first cycle. The rotational moment can be determined by iteration process. So first we will go to the joint 2. So this is the joint 2. This is the joint 2. First we will go to joint 2. So here you see what is the formula. MF2, you know, sum of piston moment at joint 2 is your minus 48.89. You know this is minus 48.89, sum of piston moment at 2, and summation of M dash 1, 2, rotational moment of far ends of member meeting at joint 2. Summation of M dash 1, 2 means rotational moment of far end of member meeting at joint 2. Suppose you see this is the joint, at joint 2, two members meets 2, 1 and 2, 3, 2, 1 and 2, 3. Designate the rotational moment of 2, 1, M dash 2, 1. When you will designate the rotational moment of 1, 2, M dash 1, 2. Similarly, when you will designate the rotational moment of 3, 2, M dash 3, 2. This side M dash 3, 2, this side M dash 2, 3, 2. And this side is your M dash 2, 1, and this side is your M dash 1, 2. This is the rotational moment. Summation of M dash 1, 2 means this is the rotational moment of the far end which meeting at the joint 2. Those members which meeting at joint 2, and that member's far end rotational moment is your M dash 1, 2. You say this is 1, 2, and this is 3, 2. So M dash 1, 2 plus M dash 3, 2. This is the summation of M dash 1, 2. This is your summation of M dash 1, 2. So summation of M dash 1, 2 is your rotational moment of far end of member meeting at joint 2. This is the member 2. This end, this side, far end, and this side is your far end. This side, far end. When we will start our joint 2, and for first cycle, we know M dash 1, 2, the rotational moment 1, 2 is your 0 because this is your fixed end. So what is the rotational moment here? Here rotational moment is your 0. If the end is your fixed, the rotational moment at the end is your 0. And you don't know what is the rotational moment 3, 2 because you have to take the sum of the rotational moment of the far ends. Rotational moment of far ends of member meeting at joint 2. Sum of the means, so you have to take this moment and you have to take this moment. But in first cycle, you don't know what is the rotational moment of the far end M dash 3, 2. So what you have to take, you have to assume the rotational moment M dash 3, 2 is your 0 because this is already for fixed and the rotational moment is your 0. And this side you have to assume the rotational moment is your 0 in first cycle. Assume 0. So then what is the formula? You have to find out M dash 2, 1 and you have to find out M dash 2, 3. You have to find out M dash 2, 1 rotational moment and you have to find out M dash 2, 3 near end rotation moment. You have to find out the near end. This is near end rotation moment and this is far end rotation moment. This is your far end rotation moment. So far end rotation, when we are considering joint 2, you have to find out the near end rotation moment, and but this far end rotation moment at fixed end 1, this is 0, and this side the far end rotation moment is you don't know. You have to assume this side you are 0. So you have to find out what is the near end rotation moment. So m dash to 1 is your equal to, this is the formula already we discussed. M dash to 1 is your equal to u to 1 rotation factor to 1 into sum of the fixed end moment of joint 2, sum of the fixed end moment of joint 2 plus summation of m dash 1 2. That is the far end rotational moment, sum of the far end rotation moment. Far end rotation moment is your this one and this one. So this 0 and already this is your assuming 0. So you have to put here m dash to 1 is your equal to. So what is the rotation factor here? Minus 1 by 4. The rotation factor is minus 1 by 4. Minus 1 by 4. And what is the fixed end moment of the joint 2? Fixed end moment of joint 2 is your minus 48.89. Minus 48.89. And the far end rotation moment, this is 0 and this is 0. This side 0. 0, 0. What is the value? 12.22. You got the near end rotation moment m dash to 1. So 12.22. Here you have to put this rotation moment. You got this moment. Then what you have to find out? You have to find out m dash 23. Similarly, you have to take the far end rotation, this side 0 and this side is your assuming 0. So here also m dash 23 is your minus 1 by 4 and fixed end moment is of the joint is your minus 48.89 plus far end rotation this side and this side is your 0, 0. Similarly, m dash 23 you got here 12.22. Here you have to put this value. Then what you have to do? So after getting these two near end rotation moment, then you have to go to the joint 3. So similarly here also you will find out. So when you will consider this joint, so you have to find out what is the near end rotation moment, this side and this side. And you have to take the far end rotation moment. So far end rotation moment for this side already you know. This is the moment. So you have to consider this is as a far end rotation moment this side. And this side the far end rotation moment is your 0 because this is your fixed. Fixed, this is your the rotation moment is your 0. And here you got 12.222. So when you will consider the far end rotation moment, so one side is your 12.22 and one side is your 0. So you will find out what is the near end rotation moment this side and this side. So this is the formula. So joint 3 m dash 32. You have to find out m dash 32. M dash 32 u32 mf3 plus summation of m dash 23. u32 you know the rotation factor u32 minus 1 by 3 and mf3 you know 46.67 mf3 minus 1 by 3 mf3 46.67. Then summation of m dash 23, the sum of the far end rotation moment. So when you are considering this joint, the far end rotation moment is your this one and this side is your 0. So here you have to take 12.22 plus 0. 12.22 plus 0. So here you got minus 19.63. So you have to put this value minus 19.63. You got this one. You got this one minus 19.63. Similarly, you have to find out m dash 34. So m dash 34 is equal to u34 into mf3 plus summation of m dash 23. This one. M dash 23. mf3 plus summation of m dash 23. So you know u34. U34 is the rotation factor minus 1 by 6. Minus 1 by 6. And you know mf3 also. mf3 46.67 plus and you have to take the far end rotation moment. Far end rotation moment is your this side is your 12.22 and this side is your 0. This is 12.22 plus 0. After taking this one, the m dash 3 for you got minus 9.82. Here you put this minus 9.82. Now first cycle is over because you got the rotation moment m dash 21, m dash 23, m dash 32 and m dash 34. And at the end, if the end is your fixed, at the end the rotation moment is your 0. So now first cycle is over. Then you have to go for the second cycle. Then in the similar way, you will find out what is the rotation factor m dash 21, m dash 23, m dash 32 and m dash 34. So you have to go to joint 2. When we will find out at joint 2, so similarly you have to find out m dash 21 once again, m dash 21 and m dash 23. So when we will consider m dash 21, what you have to take rotation factor into the fixed end moment of joint 2 plus sum of the far end rotation moment. When you are taking the sum of the far end rotation moment, so here this side you are 0 and this side you got the rotation moment. Far end rotation moment you have to take minus 19.63. Cycle 2 minus 1 by 4 minus 48.89 plus 0 minus 19.63. So here you got 17.13 kilonewton meter. You got again this value. Similarly, find out m-23. When you find out for m-23, similarly u23 rotation factor into mf2 plus summation of m-12 far end rotation moment. So what you have to take? Minus 1 by 4 into minus 48.89, and this side of the this is your 0, this side is your minus 19.63. When you have to find out for this, so this side the far end is your 0, this side is your 19.63. So already you know 0, 19, so this is your 17.13. m-23 is your 17.13. m-23, so you have to put here 17.13. Then you have to go to joint 3. So again you have to find out m-32 and m-34. When you will find out m-32, so you have to take the rotation factor into the fixed end moment of joint 3 plus summation of far end rotation moment. When you will find out the far end rotation moment, so you have to take this moment because you got this is in second cycle you got the rotation moment of the far end this side 17.13, this is your 0. So in second cycle you have to take this value. So here you got my m-32 is equal to minus 21.44. Here you got the rotation moment m-32 is minus 21.44. 32. So here minus 21.27. So here you have to put this value. Again you find out for this one the rotation factor u34 into mf3 plus summation of m-23. u34 is your minus 1 by 6 into mf3 is your 46.67 plus sum of m-23. So far end rotation moment 17.13 and this side is 0. So 17.13 plus 0. So you'll get minus 10.63. So you have to put this value here. So now second cycle is over. Then again you have to go for the third cycle. Third cycle, similar way, we'll find out what is the rotation factor m-21, then m-23, then m-32, then m-34. So when you will find out m-21, so what is the far end rotation moment you have to take? Here you have to take this one. Here you have to take this one. And for m-23, you have to take the far end rotation moment also this one and this one. So you will get what is the value this side and this side in third cycle. Joint 2, so you have to take 0 and minus 21.27. 0 and minus 21.27. This side 0, this side minus 21.27. So you will get 17.66. You will get 17.66. And this side also, other side also 17.66. So 17.66 you will get here. And this is also you will get 17.66. And then when you will go to the joint 3, so here you have to take the far end rotation moment 17.66 and this side is your 0. So you will get this value. And you know these two, rotation factor and the fixed end moment of joint 3. But you have to take the far end rotation moment is your this one. So in third cycle, minus 1 by 3, 46.61 plus 17.66 plus 0. This side is your 17.66. This is your 17.66 and this side is your 0. Here you got minus 21.44 kilonewton meter. So you have to put here minus 21.44 kilonewton meter. Then again you have to find out for this one. So when you will find out m-34, so the far end rotation moment you have to take this side 17.66, this side 0. So you will get minus 10.72. Again you see there is a difference 17.13, this is 17.66. The difference is your more. That's why you go another one more cycle, cycle 4. Cycle 4. Again you go to joint 2 and joint 3. Find out joint 2. Joint 2 again when you go to the joint 2, you have to take u21, mf2 and some of the far end rotation moment. So for far end rotation moment, what you have to take here? This side you got minus 21.44 and this side 0. Minus 1 by 4 into minus 48.89 plus 0 minus 21.44. So here you got 17.58. Similarly, m-23 also minus 1 by 4 minus 48.89 plus 0 minus 21.44. So this side also the value here 17.58. So you put this value here 17.58, and here this is also, so this is 17.58, and this is also, here you got 17.58. Similarly, you go to the joint 3 and find out this rotation on near end, this. So you have to take far end is your this one, and this side is this one. Minus 1/3 into 46.67 plus 17.58 plus 0. So here this value is your minus 21.42. Similarly, here this side also you will get this is minus 10.71. Finally, you see the differences are very less, 17.66 and 17.58. And here this is, you see, 17.66, 17.58, 21.44, 21.42. So then you stop here. For the final value, you have to take the rotational moment. M-1, you have to consider this one. And for M-23, you have to consider this one. And M-32, you have to consider this one. And M-34, you have to consider this one. You have to take the final value. You have to find out the final moments. The final moment that you can find out, this is the formula. For final moment, M21 is equal to M21 plus 2 M-21 plus M-12. Twice the near end rotation moment plus once the far end rotation moment. So M21. So M21 is this one. So twice the near end rotation moment. So when you consider this one, so this is near end rotation moment. This is far end rotation moment. So twice of this value and once this one. And the piston moment is this one. Piston moment this one, twice this one into plus this. So here you see MF21 plus 2 M-21 plus M-12. This is twice. This is your piston moment. This is twice of this one, and this is 0. M-12 0. So here you got 52.94. This is the final moment. Similarly, M12, when we are considering 1-2 near end, this is far end. The near end is your 2 into 0, and far end is your 1 into 17.58. And the piston moment is your minus 35.56. So here minus 35.56 plus 2 into M-12 0, and the far end is your M-21 17.58 minus 17.98. So when we find out M23, so MF23 plus twice the near end moment and once the far end moment. So when we consider 2-3, so this is you have to consider near end moment, and this is you have to consider far end moment. So twice of this plus once this one, 2 into 17.58 minus 21.42 plus this piston moment. So MF32 at 2-3, MF23 plus twice M-23 plus M-32 minus 66.67 plus 2 into 17.58 minus 21.42. So this is the final moment. Similarly, you can find out M32, MF32 plus 2 M-32 plus M-23. So here M32 is your 41.41 kilonewton meter. Similarly, M34, MF34, 2 M-34 plus M-43. This is near end rotation. Always you have to take the formula your twice near end rotation moment plus once the far end rotation moment. And this side the piston moment. So MF34 is your minus 20, M34, MF34. And this is the near end rotation moment, and this is the far end rotation moment. So twice into near end plus far end. So this is the final moment M34. Similarly, this is your M43 final moment. So these are the final moment. So this final moment you can find out also in this tabular form, because this is the fixed moment, and this is to the near end moment, and this is the far end rotation moment. This is fixed end moment for M-21. This is your near end rotation moment, and this is the far end rotation moment. This is the final moment. And for M-23, so this is twice near end rotation moment, and once the far end rotation moment. This is the final moment. And these are the fixed moment. In this tabular form also you can find out the final moment. Similarly here M-32, this is fixed end moment, and this is twice near end moment, and once the far end moment, and this is the final moment. For M-34, this is the near end fixed end moment, this is twice near end moment, this is the far end moment, and this is the final moment. So these are the final moments. So what you got here, the same value also you can find out using this type of table. After you can plot the bending moment diagram. So for bending moment diagram, this is your 17.98 and 52.94 here, and here 41.42 9.42, and here the moment is 9.29. So join this one. So this is the negative bending moment diagram. Then you have to find out the free bending moment diagram. You have to find out what is the maximum positive moment for span 1, 2, because here there is you are having eccentrical loading. What is the positive moment? WAB by L, 53.33 kilonewton meter. And for maximum positive moment for span 2, 3, because here having UTL. So what is the positive moment? WL square by 8, 100 kilonewton meter. And maximum positive moment for span 3, 4, here having the point load or at the midpoint. So what is the positive moment? WL by 4, plus 40 into 4 by 4. So these are the positive moment. This portion is cancelled, and this is the remaining bending moment diagram. Negative, positive, negative, positive, negative, positive. So this is the final bending. So you have to find out what is the maximum positive moment here. So you know already that is in a slope deflection and moment distribution method, how to find out this one. And what is the maximum positive moment here, and what is the maximum positive moment that you have to find out. Okay, this is the bending moment diagram. Stop here now.